Well, just when you think you've got it about figured out with one line on a coordinate plane, we're actually going to add a second line. We're on 5E, page 32, and I guess I want to start by saying if you've got two lines on the same coordinate plane, three things can happen. One of three things will happen. So for two lines graphed on same coordinate plane, I'm just going to put CP, one of three things will happen. The lines will cross somewhere along the way. They'll intersect. Number two, the lines won't ever cross. And the third thing that could happen is not only do the lines cross, but the lines cross and are perpendicular to each other, meaning they form a 90-degree right angle. So we're going to talk about the special situations where the two lines don't ever cross, and if they don't ever cross, that means they're parallel to each other. They're the same distance apart forever and ever and ever. Amen. And we're going to talk about the situation where the lines do cross, but they cross and they make a 90-degree angle where they intersect each other. So it's really cases 2 and 3 that we're talking about in section 5E. So we've got some special symbols for perpendicular and parallel. You may be familiar with them. Mathematicians are full of symbols because we don't like to write. We like shorthand much better. So that means parallel. A is parallel to B. Line A is parallel to line B. This is what it looks like. They're equidistant apart, so they never touch each other. This is the symbol for perpendicular. It kind of looks like a right angle. One comes into the other one at a 90-degree right angle, and this is what it looks like when they intersect. Of course, they make a right angle, and that's the symbol for right angle. So there's a couple special properties about parallel lines and perpendicular lines that we're going to notice and we're going to practice in this session. So we've got this equation, this blue line right here, and it's given to us in slope-intercept form. So we know the slope is 1/3, the rise over the run. We know it intercepts the y-axis at -2, which indeed this picture shows. One thing to know about a parallel line is that it is going to have exactly the same slope as the line it's parallel to. So in this case, they're asking us to graph a line that's parallel to the line that we see, this one right here, but they're giving us the y-intercept of +1 and write its equation. So let's graph it first. We know that the slope is going to be the same as the line that it's parallel to, which is 1/3. So if we start at the y-intercept of 1, we know that the slope is positive, so we're going to rise 1 and run 1, 2, 3. There's a point on this line. To get another point over here, we're going to go down 1 and 1, 2, 3. So there's our line, and if I were to be able to draw a straight line through it with a straight edge, it would be perpendicular to the line that we were given. Now we need to write the equation of the line. So using y is equal to mx plus b form, y is equal to, and the slope is the same, x, but the y-intercept, of course, is now different. This line had a y-intercept of -2. Our line has a y-intercept of +1. Okay, so let's see what else they ask us to do. They ask us to graph yet another parallel line, and they give us the point that they want it to go through and write its equation. So here's the point, -2. Actually, this is a typo. I noticed this. This should say -3, 2. So go ahead and change that in your book, please. So if we go to, let me get another color. If we go to -3, 2, right here, Our slope is the same. Our slope is 1, run 1, 2, 3, rise up 1, run 1, 2, 3, and then we can go down and run 1, 2, and somewhere over there is our third point. And here is yet another parallel line to the original line and to the first line in red that we created ourselves. So now we need to write the equation of the line. So they give us a point, but they don't give us the y-intercept. So we're going to use the point slope. Now, you could probably look at the y-intercept and go, well, I see the y-intercept. It looks like it's at positive 3, 1, 1, 2, 3, and you could write it that way, or you could use the point slope formula. So the point slope formula is y minus 2 equals the slope we know is positive 1/3, and then x minus a minus 3, which would be plus 3. So that's the point slope form. If we pluck the y-intercept off of here at positive 3, we get y is equal to 1/3 x plus 3. So hopefully when you simplify this one up here, you would get this exact same equation. This is helpful. This one's helpful when you don't have a nice, neat, exact y-intercept, and that happens all the time. So if we didn't have this exact point for the y-intercept, we'd have no choice but to use the point slope form. So let's go talk about perpendicular lines. So we're given an equation. Here's the equation of the line. Here's its graph. We can see it's declining from left to right, and its slope is negative. We know the y-intercept. And they're asking us now to graph a perpendicular line through this point. So this would be the y-intercept, and write the equation. So let's go do the graph first. However, what you will notice about a perpendicular line to the original line is its slope is the negative reciprocal of the original line. So this slope, our slope of our original slope is negative 2/3. Our perpendicular line slope will be positive 3/2. It's the reciprocal, and it's the opposite sign. So let's go start at negative 2, 0, negative 2. So that's this point right here. Our slope is going to be positive 3/2. So we're going to go up 1, 2, 3/2. Let me make sure I'm doing this right. Yep. Up 3/2. And down 1, 2, 3/2. So here's our line, and he is making a 90-degree angle at that to our original line in blue. So now we have to write the equation of a line. So our slope, we're going to use slope intercept because we have the y-intercept right here. So our new line in green is going to be y equals 3/2 x minus 2. And they give us one more to do. Graph another perpendicular line through, and again, this is a typo. This should say negative 2, negative 1. And write its equation. So let me go get a different color here. Here's negative 2, negative 1. Again, our slope is going to be the negative reciprocal. Here's our original slope. Our new slope is going to be the opposite sign, so it's positive, and it's 3/2. So we're starting at negative 2, negative 1. We're going up 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And down 1, 2, 3, 1, 2. So here's a second line that is perpendicular to the original line. And this one, we need to put in point slope form because I don't know what that point is where this line crosses the y-intercept. I'm not 100% sure. I guess we did say it was 1, 2, 3, 1, 2. I guess we could say it's 3. But let's write it in point slope form anyway. Gives you a little practice. So y minus y sub 1, so y minus a minus 1 equals our new slope, 3 over 2, x minus a minus plus 2. And if we wanted to prove that this actually ended up being the same as our y equals mx plus b, which is y is equal to 3/2 x plus, and we think it runs through the y-axis at 2. Let's go ahead and do the distribution and see what we get when we turn this guy into slope-intercept form. So subtract 1 from both sides, and indeed we get y is equal to 3/2 x plus 2. So you can see that these guys are the same. Okay, thanks for watching. We will carry on. Next page.